A particle is in a state which is a superposition of the ground state and first excited state of one-dimensional quantum harmonic oscillator SHO, and the state can be defined as the linear combination of phi 2, phi 0 and phi 1, ground state and first excited stage. Find expression value of energy in this state. So how we will calculate expression energy? Like this: phi h cap phi and phi phi. If function is normalized, this will be 1. So check function is normal, whether function is normalized or not. 1 by 5 square this, and 2 by 5, 3 by square of this 2. 1 by 5, 4 by 5 equal to 1. So function states are normalized, phi is normalized, so it will give us 1. And if it's not normalized, then what will we do? We will divide the wave function with the c1 square plus c2 square. Then we will term as the no normalized function, and we will use that normalized function in our upcoming steps. But here function is normalized, so phi phi will be 1. So now we'll calculate phi e and phi. 1 upon root phi naught and 2 upon root phi 1. So E is ground state for phi naught and phi 1 is for first excited state. So for ground state, energy of simple harmonic oscillator is 1 upon root 5 phi naught, and E is 1 by 2 h cross omega. Okay, plus 2 upon root 5, energy for phi 1 will be, E is for phi 1 will be 3 by 2 h cross omega. Now we put the value of phi here again. Now do interaction with this wave function, whole wave function. So what will you get? 1 upon root 5, 1 upon root 5 ka square, phi naught will be 1, and here we are left with 1 by 2 h cross omega. Now interaction of this with this, so what will you get? Phi 1 will be 0, and here phi 0 will be 0. Now these two, this 2 upon root 5, 2 upon root 5, 2 upon root 5 square, energy is 3 by 2 h cross omega, and phi 1 will be 1. So we are left with h cross omega 1 by 5 into 1 by 2 plus 2 by 5, 4 by 5 into 3 by 2. So it will be the energy. It can also be calculated from the shortest method, shortcut method, 1 by 3, 1.3 h cross omega. How we will do it? Summation of pi ei. Expression we will calculate if the wave function is normalized. Pi ei, and pi is c square ei. So what will be c square? 1 by 5 square, 4 by 5, and ei will be 1 by 2 h cross omega, 3 by 2 h cross omega. So simply from pi ei, expression value can be calculated, 1 by 1.3 h cross omega. Now again, wave function is given to us, orthonormal given to us, eigenvectors of energy operator with energy eigenvalues of E1 and E2. Suppose energy measured is made of the state psi, what will the probability of getting energy? E1. So we have to calculate probability of getting energy E1. So P1 will be C1 square E1. P1 equal to C1 square. C1 square equal to 1 by 2. P2 equal to C2 square, 1 by 2. Psi is normalized, 1 by 2 square, 1 by 2 square, 1 by 2 plus 1 by 2, 1. 1.2 square means, so function normalized, probability of getting energy 1 by 2, 1. Okay. Suppose after the measurement we get energy E2, what will be the state of the system just after the measurement? So if we are getting the energy E2, then corresponding state will be there, so psi 2 state will be there. Suppose we repeat energy measurement process again and again, then what will be the energy, expectation value of energy for psi? So when we are repeating the energy, repeating the experiment and calculating the expectation value of energy, so shortest method PII, CI square EI means C1 square E1 plus C2 square E2, 1 by 2 N plus 1 by 2 2, 1 by 2 E1 plus. Now we will learn time independent Schrodinger equation, how we can derive wave function for time dependent part. Suppose we have wave function phi of t equal to a dot e raised to the power minus I at it by h cross. We know this. So psi rt can be written as space and time dependent. Phi of 2t equal to phi 2 prime, phi 2, and just multiplied this whole for phi 2 with our original psi r. Then we get time evolution of quantum mechanical state. we call it time evolution of quantum mechanical state. So k at psi of xt equal to e raised to the minus iota h cap by h cross t and psi x 0. So psi x at t equal to 0 will be 1 upon root 2 psi 1 plus psi 2. Psi of xt equal to 1 by upon root 2 e raised to the power minus iota h cap upon h cross into t and psi 1 plus psi 2. Just multiply this with this and this with this. Psi 1 t equal to 0 and this, psi 2 equal to 0 and this. For E1, H cap will be E1. For E2, Hamilton will be timeless energy operator E2. Now, H atom is, we will discuss about hydrogen atom. So, hydrogen atom is prepared in the state psi of RT not 3 by 2 exponential of iota E1 t upon h cos psi 1 r 1 by 2 exponential of iota E2 t upon h cos 2 r. Ground state energy psi 1 r with respect to E1, first exercise psi 2 r with respect to E2. Now in an energy measured process, the average energy of the process will be, there are certain options, and energy will be ionizing energy of hydrogen atom. So just we will extract a few information from the question. What is given? Hydrogen atom is given to us, okay, and what we have to calculate? Energy, average energy of the process. We have to calculate the average energy of the process. Average energy means the expectation value, so will be psi h cap psi. Now whether we'll check whether the wave function is normalized or not. So check 3 by 4 plus 1 by 4, 4 by 4 will be 1, so function is normalized. This will be 1, so E will be psi h cap psi, and expression will be calculated c1 square E1 plus c2 square E2 like this. For hydrogen atom we know E1 is minus E naught and wave function is defined as psi 1 and psi 2 term. Okay, psi 2 term. E2 energy operator will also be needed. So we know ground state energy minus E naught and E2 equal to minus E naught square. E square means E naught by 4. For ground state is 1 and equal to 1. First exercise result is equal to 2. So calculate energy is C1 square E1. C1 square E1. C1 is under 3 by 4 and C2 is 1 by 4. Okay, and C1 square E1 minus E naught, C2 square and E2. So when you solve it, you are getting minus 3.16 E naught. So probability of finding the particle at a certain point with respect to time will be stationary in state, or eigenstate will be time independent, means it will not vary with the time. Okay, so eigenstates are, we call it stationary states because the probability of eigenstates are not depending on the time. But linear combination of eigenstate, not stationary states, means can be dependent on probability of finding the particle. In linear combination of eigenstate can be dependent on the time. This is the point. So psi of rt equal to 1 3 by 2 psi 1 r plus 1 by 2 psi of r. When you multiply it is psi of rt. So it is a linear combination of the eigenstates, so it is not stationary state. In short, stationary states are the eigenstates. A random state which is linear combination of eigenstates is not necessarily a stationary state. Next question. Psi of xt equal to 0 equal to 4 by 5 under 4 by 5 get 5 3 by 5 phi 2. So we have to calculate wave function a certain time is given to us. So just multiply these equal to e raised to minus iota upon h cross et. Okay, so when you multiply this with this, there are two exponential coefficient here. Now interact with this phi 1, interact with this phi 2. So what will you get? Exponential of minus iota e1 upon t. We are taking common from here. Okay, so 4 by 5 phi 1 plus 3 by 5 exponential, this will go upper, so e1 will be positive minus e2 t by phi 2. This will be common, 4 by 5 3 by 5 and time is given to us. Sorry. So put t equal to h upon 2 e1 minus e2. So you are getting exponential of iota pi, which is cos pi plus iota sin pi equal cos pi equal to -1, and this is the phase factor. We call it phase factor. So option B will be correct. Now, we'll discuss about angular momentum and Jx, Jy, Jz or Lx cap, Ly cap and Lz cap. So Lx is h cross upon 2 0 1 0 1 0 1 0 1 0. Okay, remember this, very important. Ly is h cross upon 2 0 minus iota iota 0. And L cap Z h cross 1 0 0 0 0 0 0 0 minus 1. Okay, you have to remember this. Okay, there is no other option. So you can, there is a trick, you can remember x, Lx is like this 1 1 1 1 or else are 0, and here also 0 minus iota iota 0 and 0 minus iota iota 0, all else are 0. Diagonal element is 0, here also diagonal element is 0. Getting my point? Iota minus iota, iota minus iota. This is very easy. Okay, just do this 0 0 0 0 0, put 1 1 1 1, and here 0 0 0 0 0 0, and symmetric to this I minus iota, I minus iota, and this is very easy, 1 and minus 1, rest are 0. Hope you got it. So just do this. Okay, like this, this will be 0 1 1 1 1. Yeah, matrix complete. This 0 0 0 0 0, iota minus iota, iota minus iota, and 1 minus 1. So this will be the angular momentum operator x, y and z with respect to x, y and z direction. Now we have to calculate the eigenvectors for this. Okay, eigenvalues is 0, h cross 0 minus h cross 0 minus h cross 0 and minus h cross. Eigenvalues very easy, but you have to calculate the eigenstate for this. So eigenstate for h cross will be 1 by 2 1 upon root 2 1 1 upon root 2 1 0 minus 1 1 upon 2 1 minus root 2 1. Try to remember this also, because in exam you are not able to calculate that past. So you know the process, but you have to remember this also. Now h cap 0 and minus h cross 1 upon 2 1 upon 2 1 under 2 iota minus 1 1 upon under 2 1 0 1 1 by 2 1 minus under 2 iota 1 minus 1 1 0 0 0 1 0 0 0 1. Very easy peasy. Diagonal, because this is diagonal. Operator is written in a particular representation, a complete set of basis state. We call it the psi and psi are operator, Bryant form. Suppose we are having a new operator S 1 2 3, and I is orthonormal vectors, and 1 to second percentage 1 0 0 1 0 1 0 0 1. So Lx can be represented as like this in matrix form. This one Lx 1 1 will be 1 1 1. This 1 Lx 1 1 Lx 2 and 1 Lx 3. Similarly 2 Lx 1 2 x 2 2 x 3 3 x 1 3 x 2 3 x 3. Now you can calculate the operator with this matrix. Similarly, you can return for Ly and Lz. If operator is presented in its own eigenstate representation system, then the matrix representation of that operator will be in diagonal form. Now L cap Z is diagonal, so it will be very easy for L cap Z. Psi NL ML ML H cross psi NL ML. We know linear angular momentum at Z in that direction ML H cross psi NL ML. So for L equal to 1, S equal to 1, we have calculated this. For L equal to 1, ML equal to minus 1, 0 and 1. So just put it minus 1, 0 and 1. Okay. And psi NL ML, N11, N is fixed, and LML. So for L equal to 1, ML equal to 1, 0 and minus 1. For 1, 1 0 0 1 0 0 0 minus 1. So it will be give you 3 values. So LZ cap 1 1 will be 1 LZ 1 H cross 1 1 2 2 3 2 1 3 1. Just calculate this, and for diagonal element 2 2 will be 2 2 is not 0. LZ 2 2 is 0. Why is this so? Because for 2 2 this 0 is MLH cross. So it will give you 0. Okay. Similarly for this 3 will be 3 2 1 will be 0. So we are having only 2 rest are elements are getting 0. So similarly, escape and escape are also written in the eigenvalue of LZ. Now psi 1 by 2 1 and 2 1, psi 2 1 upon 2 1 0 minus 1, psi 3 is this. So we can define the 3 states 1 ket 1 equal to 1 0 0 in between psi 1 psi linear combination of psi 1 psi 2 and psi 3. From here 1 0 0 is 1 by 2 c1 by 2 and c2 by under 2 and c3 by 2. Similarly 0 is under 2 by 2, 0 upon 2 minus 1 under 2 upon 2, and similarly for 1 by 2 minus 1 upon 2 1 by 2. Now a linear vector space equipped with an orthogonal basis of phi 1 phi 2 and phi 3 operator AK acts on the basis vector as follows. AK is rotating phi 1 2 phi 1, AK is operating on phi 2 3 phi 1 minus phi 2, and AK phi 3 is giving this. Compute the matrix representation of AK is given instead of basis. Same question as we had discussed above. Okay, so how it will approach this question. So we'll check if representation basis states are same as operator, then we call it eigenstates. So check this representation basis states is same as eigenstate. Yes, phi 2, there is no phi 2 here. Okay, so representation of basis states is not same as operator's eigenstates, so it will be not diagonal form. Now it is not in diagonal form. Now we'll operate this phi 1 phi 2 phi 3 phi 1 phi 2 phi 3 a11 a21. We have to calculate a11. So phi 1 a cap phi 1 and a cap phi 1 is given to us. When you are operating a cap to phi 1 is 2 phi 1. Okay, so we are in a cap phi 1 is 2 phi 1. So 2 phi 1 is operated on again phi 1. So it will be for 2 phi 1 phi 1. So it will get your leave us with 2. Now phi 1 a cap phi 2 means a12 element of the matrix, and it is given to us a cap phi 2 is 3 phi 1 minus iota phi 3. So just operate bra phi 1 on this operator. So bra phi 1 will operate 3 phi 1 phi 1 minus iota 3 phi 1 phi 3. So it will lead to 0, only 3 will be there. Similarly you can calculate the rest element also. Now psi of r is given to us as eigenvectors of the Hamiltonian instant motion notion. So energy operator, we have to calculate expression value of energy. What we have to calculate? Expectation value of energy. So check normalization is not, whether it is the wave function is given to us is normalized or not. So 1 by 6 2 upon 3 plus 1 by 6. Yes, 1 normalized. So C1 and C2 C3 are probability amplitudes. Now we have to calculate energy operator for this and this. N is fixed, only L and M are changing. So for N is fixed, so energy is N naught upon N square, so N naught by 4. And N is fixed, N naught by 4. Here N is changing, so energy will be changed. And PII C1 square E1, C2 square E2, and C3 square E3. Getting my point or not? Put the energy for E1, E2 and E3. These are not the stage, okay? This is the wave function psi 1, psi 2 and psi 3. Here phi 1 and phi 2 and phi 3, okay? N is changing only for the third wave function, phi 3. Now the state vector of 1 dsh of angular frequency omega at time t equals 0 is given by this. Ket psi, ket 0 and ket 2 are normalized ground state and first second steady state respectively. The minimum time after which we have to calculate the time. The state vector of psi t is orthogonal to psi t equal to 0. So given is psi 0 is orthogonal to psi t, means it will be 0, and bra psi not equal to given to us. So we'll find out ket psi. We know this multiplied is e raised to minus r to minus cross h cap t. Ket psi is given to us. Getting bra psi is given to us. We are calculating ket psi. So just reverse it. So we are having now ket psi, and for energy state of SHO, ground state is 1 by 2 h cos omega, and second state is 3 by 5 by 2 h cos omega. Put it here. Now psi of 0 and psi of t. This we have to also know psi 0, and we can reverse it also. But if you reverse it, you will calculating psi of t. Okay. Yeah. Given is the wave function given to us in ket form. Okay, and we have to calculate time dependent wave function in ket form also, because in bra form we can reverse it. There is no complex conjugate, so we can easily make bra form of psi of t. And it should be equal to 0. So this whole part will be 1 by 2 will be 0, 0, 0, 1, 2, 2 will be 1. So we are having with this, and when you divide with this, so this will be 1 plus 2 minus iota 5.2 omega t minus plus iota omega by 2t. Okay, so 5 plus 1 minus 4 to 1. Now check from the option t equal to pi upon 2 omega. Put t equal to pi 2.2 omega here, and we are getting e to minus pi iota. So it will be cos pi plus iota sin pi. So cos pi will be minus 1. Only this is satisfying the above equation. Now ground state energy of an anisotropic harmonic oscillator described by the potential energy V of xyz equal to half omega s square plus 2 is. Now we have to calculate the ground state energy of this in terms of h cos omega. So what is this mean by anisotropic differential? Anisotropic means the property is different in different direction. Now for the harmonic oscillator, we know psi can be written as in form of x, y, z. Energy can be written as ex plus ey plus ez, and energy can be written as nx plus ny plus nz. 1 by 2, 1 by 2, 1 by 2, 3 by 2 h cos omega for isotropic. Now this is for anisotropic. So nx plus 1 by 2 h cos omega x, nx plus ny plus 1 by 2 h cos omega y, and z plus 1 by 2 h cos omega z. So energy for this anisotropic will be in this form. Now we have to calculate the omega x, omega y, and omega z. So for this we have to we are given potential. Okay, this we have to calculate, and we are given potential here. So what is this? Half m omega square x square plus half m. We have to calculate nx, ny, and nz form. Okay, so this is omega square x square, half m omega square y square. Here omega is means 2m omega square y square can be written in this form. Why it is so? Because we want to calculate omega x, omega y, and omega z. Rest we have to calculate omega x plus omega y plus omega z. So try to manipulate this form in this form. Okay, so half m y square, and omega can be written as 2m omega square, means you square it and cancel it, it will be here. Now here 8 also. So how we can calculate 8? 4 divided by 2, 4 divided by 16 divided by 2. 16 divided by 2 is 8. So 4 omega square. So we are having omega x, omega y, and omega z. Put it here. Omega, 2 omega, 4 omega. So nx plus 2ny plus 4nz, 1 by 2, and 2 into 1 by 2 plus 1, 4 by 2, 2 h cos omega, 7 by 2 h cos omega. Rest we will do later. Thank you very much.